This is the important video in test project. Here we are going to perform triangular trajectory motion in X plus button. I'm going to jog the robot or Gantry robot using X plus button. Similarly, we do the same thing for X minus Y plus Y minus Z plus Z minus. I'm going to use the same code which we have written earlier for triangular trajectory with a few modifications. First thing is structure. I'm going to introduce structure. See here, there is a structure, profile, and points. So I'm going to use that. Then second one is the program run from one point to another point. So I will explain. This is a template which we have used in Qt OpenGL video. Okay, same template, but all the buttons are empty. So you have to write a code for X plus, X minus, Y plus, Y minus, Z plus, Z minus. Anyway, in this video, we are going to write a code for X plus. This is a structure. So we have already written a triangle C program where we didn't use structure, but here we are going to use structure. When you use structure, you can easily pause n number of variables using one single structure. That is why we are using structure. So here you have to write a code for each function. So this is a GL widget function. So you can insert your OpenGL code into this GL widget.cpp file also, so that you can easily see the animation. Anyway, we will start with main window.cpp. So in this, almost all the functions are empty. You have to write a code. Already you have written a code for delete, insert functions, but now we are going to write a code for X plus click. So this is the GUI window. So first run this code. You will get a window like this, and you are going to write a code for X plus. You can copy the same code for X minus, Y plus, Y minus, Z plus, and Z minus. So we have different buttons. You have already done insert, delete, unload program function. So now you are going to do program for X plus button. Select X plus, right click, click on go to slot, select click, you will come here in main window.cpp. So this is where I'm going to write a code. Okay, first I'm writing some basic codes to get the input data from combo box and radio button. First I'm writing QStream speed. So we need two inputs for our profile. So those two inputs are speed and distance. First I'm getting speed input using the combo box 9. You can check whether it is combo box 9 or some other values. So I'm get a value through current text. Then again QString distance. I'm going to get distance value. So these are all the two input values which we need to pass it for triangle function. So I'm going to get these two input using combo box 9, combo box 8, and current text function. When you use this function, whatever the value you have selected in the combo box directly goes into the corresponding string, namely speed and distance. So these are all string values which I'm going to convert it into float. So float speed equal to speed to float. We are converting string into float. So this is a command. Similarly, you can convert distance value which is already available in string into float. So now we have both speed and distance inside X plus click function. I'm going to use the same code which you have typed or executed earlier, okay, for triangular trajectory function with a few modifications. The first thing is we are going to execute structure. Then second thing is I'm going to modify the starting and end point so that you can uh, you can jog x plus for n number of times. So that is the only thing. So now you see here, I'm going to use structure PTS points dot x2, which means I'm going to use a structure point. PTS is a structure. Inside the structure, I have a lot of variables x2, x3, x1. So you can get those values through dot x2. So endpoint equal to x3 plus distance. So whatever the value we are x2 is the endpoint. So x2 is nothing but x3 plus distance. X3 is the starting value. First time x3 is 0. Next time x3 will be x2. So that I am going to set it here. Then pty2 is nothing but pty11 because I am going to jog only x direction, which means y there is no change in y. So starting point, end point for y and z direction same. Then another thing here I'm going to write a trajectory for three-dimensional, not one-dimensional. Earlier we have written for one dimension, only one direction, whereas here it is for three direction, x, y, z. Then only we will get a 3D shapes. So here I have specified some points. So pt2 dot x2 means end point equal to x3 plus distance, whatever the distance I would like to move. Then y2 same as y1, z2 same as z1, which means there is no change in y2 and z2 because I'm going to move only x direction. If UI main window radio button is checked, which means if triangle radio button first radio button means triangle function selected, then execute triangle function. So triangle X, this is very important, not just triangle. So we are executing triangular trajectory along x-axis. Here we are giving an input of speed. So you can pass both input distance and speed, or you can pass speed alone. So here I am passing only speed. If you pass the speed alone, you have to find the distance. So how do you find distance? There is a formula to find distance. I will show you that formula while it is coming. Now I'm going to write a for loop. After executing the triangle function, we will get some values, triangular trajectory values. That value I have to pass it to Qt OpenGL. Then only you will get uh, animation. But anyway, I just remove those values. So instead of that, what I'm going to do is after executing the triangular speed trajectory, I have to set the starting and initial point. So points x1, PTS x1 equal to x3, which means starting point value equal to x3, then s equal to 1. J11 equal to 0. So these are all like a switch buttons we are using. So when S equal to 1, what happen? Then only the OpenGL function will run. J11 equal to 0, which means then only it will start executing array values from OpenGL. Okay, so now what I'm going to do is I'm going to copy the code. Okay, so we have already written a code for triangular trajectory. So that I am going to copy, and here I am running this function. There is some error which I have to identify. So once you identify those errors, we will move on to triangular trajectory function. So now I am opening the code which we have written in the previous classes. So this is a triangle profile code. I hope you have written a same code. Just copy the complete code. So you have to copy a code from this point. I mean, from float increment to the end of the program. Okay, copy the code. So this is a code, I mean C program for triangular trajectory to execute a displacement from 0 to 300. So to copy this code, and we are going to use this code inside triangle X. Okay, inside the triangle X, we have to do some modification because and that see here we are passing only the speed value. So you have to find a way to calculate distance. Then another thing, we are using 3D coordinates. So what we have done earlier is only we have written a trajectory for one axis, whereas here you have to write a trajectory for three axis. Three axis means x, y, z. So you have to execute trajectory on all three axes. So float increment you have to find, then float distance. So there is a formula for distance. So this is a formula. Square root. I'm going to type a formula. This formula is nothing but a distance between 2 points. There is a standard formula which has been used in schools to find a distance between 2 points. So how do you find the distance between 2 points? X2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So you have to take a square root for the entire function. So this is a very simple formula to find a distance between 2 points, and these 2 points are 3D points. 3D means you have x, y and z values. So how do you type this equation in C program? Just listen this code. So this is how you have to type. Okay, now you see that there is a power function POW which will find square x squared x2 minus x1 squared. For that square, we are using this power function. So you have to put brackets properly. So square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. All these values x2, x1, y2, y1, z2, z1 are specified in the program. There are few values are specified in the template, few values are specified in the previous lines. Okay, which means you can find distance using points. So there is no need to pass speed value inside the triangle function. That's why I'm used only speed as an input to triangle function. So next, all the remaining formulas are almost same. You have to find increment, you have to find time Vmax, you have to find error, everything same. You don't need to change anything. So whatever the program which you have typed in earlier, same thing. There is no change. But we are doing on small changes only at the end of the program. Instead of G, you have to type it as P dot G because we are passing G inside the structure. So there is a structure called, see here, there is a structure profile where I can pass X, Y, Z value. Similarly, there is a structure called points PTS where we are passing starting and endpoint values. See here, G, float G comes inside the structure profile. So profile defined as PTS. See here, profile defined as PTS. So you have to type it as PTS dot G. So that will give you G value. Similarly, okay, so this value X2. So it's nothing but P dot X2 point. So wherever you see x2, x1, y1, you have to convert as p dot that corresponding value. So PTS, sorry, P not P dot PTS. Points are mentioned as PTS, PTS dot x1, PTS dot x2. So P dot P means position. So starting position equal to PTS dot x1. Okay. Similarly, Here there is no need to specify x2. We will see that later. Velocity and position. So velocity also p dot v, because we are using a structure called capital P. So inside the structure only we are passing velocity and position. So make it as P. Then starting by x2, x1 are points, starting end points, which we are passing through structure PTS. So PTS dot x2, PTS dot x1. There is no change in formula. Only thing is the notation we are changing. Other than that, remaining are same. Instead of G, we are giving P dot G. Instead of X2, we are giving PTS dot X2. Like that only we are doing changes. So other than that, there is no change in the program. Okay, so now I almost completed the program. Now I'm going to run the program. Click on run, or you run the application by right clicking on integrate. So you may get some error which you have to clear. So there is a bracket issue. So there is an extra bracket which I have to remove it. Yes, there is an extra bracket. So I'm going to remove that bracket. Okay. So now you probably won't get any error. Okay. So now there is no error. So now click on X plus. Before that, select distance and speed. So I'm going to select distance as, so watch this carefully. This is where you can understand it clearly. 10, speed 1. Select triangle profile, click X plus. You can see it will run up to 2. This is a triangular trajectory. Now you press X plus again. It will run from 10 to 20. Now you see that? No, it didn't run from 10 to 20. So there is a mistake. So this is a reason why we are making some changes on triangle profile. What you have done in the previous class, you have written a code. It will run only from 0 to 300. When you press again, it won't run from 300 to 600. But here, what we are doing is, when you press that X plus button continuously, it will keep on moving to next distance. First 10, next it will move to 20, then 30, then 40, like that it will move. I think we have to activate that line on 179. There is a line in 179. I'm just checking where is the mistake. I think there is no mistakes. Maybe we will run once again to check. Actually, I have to paste this code. So this is to initiate G. So you paste this code here, then you run the simulation once again. Now you select distance, speed. Okay, now you press check, select triangle, press X plus, you will get up to run up to 10. Okay, so now I'm going to press once again. Still I'm getting error. Okay, yes, now it works. Now it will move up to 20. Now you press once again, it will move up to 30. So this is a difference in trajectory. So that is why we have done some modification in the C program. Whenever you click on X plus, it keep on increasing. Okay, so this is a code for X plus button. Similarly, you have to write a code for X minus, Y plus, Y minus, Z plus, Z minus. So this is a reason why I'm using structure. If you didn't use structure, then you have to define a lot of points, which may be difficult. Now you see that I'm going to paste the code for X minus. Okay, just copy the code, whatever already available in X plus. Okay, so this is like some changes that we are doing. Okay, so you run an application. I will show you once again. Select distance 10, speed 1, Select triangle, press X plus. So you can see the motion trajectory. See 10, 20. When you press once again, it will move to 30. 30. You press once again, it will move to 40. Or you may change the distance and again you can press. So when you every time when you press, it will move from previous point to next 10 values. So that is the one thing that we have done in this code.